Ever wondered how a drone could navigate a city, forest, or disaster zone on its own? What if it didn't need step-by-step instructions, but could just understand a goal like find the red car or locate the child in a green shirt? That's the bold vision behind a groundbreaking AI research project called UAVON. Let's break it down. Traditional drone navigation often relies on detailed instructions, like a robot following a script. But real-world environments are messy, unpredictable, and full of surprises. That's where object goal navigation comes in. Instead of telling a drone exactly what to do, we give it a semantic goal, like find the tree or locate the person with a backpack. The drone then uses its sensors and AI to figure out how to get there. But here's the twist. UAVON isn't just for ground robots. It's designed for aerial agents, drones flying in open, complex environments. Think of it as training a drone to explore a city, avoid buildings, and spot a specific object, all without a map or GPS. The researchers created 14 hyper-realistic environments using the Unreal Engine, from urban streets to forests and waterways. Each scene has over 1,000 annotated objects, like a small human in a green shirt or a red bicycle, each with detailed clues about their size, shape, and visual features. This isn't just about finding objects, it's about teaching drones to reason. Can a drone understand that a child in a green shirt might be sitting near a tree? Or that a dark truck could be hidden behind a building? UAVON forces AI to tackle these real-world challenges: obstacle avoidance, dynamic movement, and interpreting ambiguous goals. The team tested their benchmark with a baseline AI called AOA, a zero-shot system that uses a pre-trained AI model to process visual clues and generate actions. But even AOA struggled. The results showed that aerial navigation with semantic goals is much harder than traditional methods. Drones can't just teleport or follow a map. They have to think, adapt, and explore like a human would. So why does this matter? Imagine drones that can search for survivors in a wildfire, deliver medical supplies to remote areas, or inspect infrastructure without constant human input. UAVON is a stepping stone towards smarter, more autonomous aerial systems. And the best part? The benchmark and code are open source, so researchers worldwide can build on this work. Now let's dive into the math behind the magic. How do drones actually think through these complex tasks? Picture a drone on a treasure hunt. To avoid infinite loops, researchers calculated the maximum steps it should take. They used the drone's cameras, which see 90-degree angles, to map a grid. At 5 meters up, each square in the grid is what the drone can spot in one shot. With a 50-unit radius, that's 88 squares to cover. A perfect zigzag path would take 92 steps, but real life isn't perfect. Add in obstacles or a random starting point, and they round it up to 150 steps, thorough enough to search, but not so strict it gets stuck. But how do you measure a drone's success? The team tested strategies like AOA-F, which moved straight and steady toward targets, and AOA-V, which explored widely but struggled to stop when it found something. Then there's CLIP-H, which took smart routes but sometimes quit too early. The lesson: even the best AI needs clear goals, smart planning, and reliable stops. This isn't just about drones, it's about teaching machines to understand the world step by step. Next time you see a drone, remember, it's not just flying. It's interpreting, reasoning, and learning, just like us. Thanks for watching, and stay curious.